this session number 360 and no, is 17. Uh-huh. Um, it's 70. And sorry, welcome to this session. And today we continue with this problem. A few minutes ago, I was checking Twitter and I seen an comment related with the leetcode about a new feature where appear how many people are. Yeah, here. Do you see? Nice. I like because in this way I think that you don't feel alone with this problem. I another people are trying to do this problem. Let me check. What is the problem of today? I think that this. Oh my gosh. Yeah. Okay. Wow. I like it. I very like it. Too much this. Okay. This. Okay. Nice. Well. The problem in this case said that you have the problem is employee free time, and the idea is that you receive a list of lists where every list represent the times where the worker or the employee is working. Yeah, and basically you need try to find the space between these work hours or work time where everyone shared this time, you know. And I had the idea to use the priority queue. Come on. Okay, yeah. This, for example, this is the input that is a list of lists. We need remember that we are using objects instead a simple array. Yeah, but well, it doesn't matter this now. Okay, for example, we have this the people with the color this. Yeah, basically have the time between 1 and 3, and this, for example, do you imagine that this is the answer? 4, no, here is between 3 and 6, this is the space. Yeah, and here is between 6 and 7. Yeah. Now for the next is basically this, and is between the 2 and 4, and here, for example, don't have any free space, and the last is basically this. Yeah, in this case is 9, 12. Yeah. Okay, now what is the idea with this problem? Well, the idea is basically find the space between these. Means that we need to have the minimum and the maximum value and try to search it because, for example, here appear a new one, 7 to what is the maximum? 12. Yeah, and this is the same, 7 to 12, but here appear 1 to 2, and here appear basically between 1 and 9, and that's it. Yeah, and we need to find this space. Now for do this, I had here I had the idea to use the priority queue only for keep the order in yeah, basically for this is only for the order, but first is try to put this in No, it's with this, with the priority queue. Yeah. For example, with the priority queue, configure that take the start. The start is this, and this is the finish or end. The start and end. No, finish. Start and finish. Basically, take the first as a reference, but taking the second as a reference too. Yeah. Now, for example, in this case, taking these two criteria to sort or to put this element in the priority queue, and the priority queue take these two reference for sort this array or these elements is basically 1, 3. What is the next? Okay, the next we have this and we have this. What is the next? In this case is this because contain the minor element here. This and this is the same, but this and this, the minimum is this. Means that 2 and 4. Now the next that is 2 and 5. What is the next? The next is 7 and 6, and the last is 9 to 12. Yeah. Now we have the minimum and we have the maximum because in the problem don't set that we need to start in 1. This case said that can start in 0, but it's not a constraint. It means that we need to take what is the minimum, and the minimum basically is the first element. We need to remember that the priority queue have the natural order. Means that the natural order is increase. Yeah, and in this case is increase. And having this basically is only apply this. Search the space between this and this. In other case, join the or merge the time. Do you remember that this is the time where the employees are working? Yeah, in this case, for example, 1 and 3, and we need compare 3 is greater than the next. In this case, that is 2. Yeah, means that this is inside this range. Yeah, and the next that is take the greater value between 3 and 4. What is the greater? Is this. Means that the new range or the new time where the employees are working is between 1 and 4. Okay, now this is done and this is done. Now the next that is between 2 and this 4 is greater than 2. Yeah, means that this is inside this range. Okay, and now we need to compare between 4 and 5. What is greater? Is the 5. Okay, now this change, this is appear, and only we have 1 to 5. Yeah, and this is done. Now the next that is 7 and 6. 5 is greater than 7. No. Okay, in this moment we find an oh no. Oh yeah. All the employees should be have free space. No, yeah, I am right. In this case, for example, 5 is greater than 6. No, means that we have a one space of the free time for all employees. Yeah, in this case, is basically take the finish and the start. Yeah, this is the first common value. And next to is add the new parameter here, 6 and 7, and it's done. Yeah. Now the next that is a 9, 12. 7 is great at 9? No. Okay, again, we find a new space the free time. And basically is 7 is the start and the start, sorry, the end of this element and the start to the next. Yeah? And now is put this value here. Yeah? And I think that in this way, you have the answer, that the answer in this case is basically 5 and 6 and 7 and 9. That that is this. Okay. Okay, now the complex here is that sort these elements in the priority queue. Again, I remember that we can configure the compare, compare the elements here, configure this compare. And I was trying to use this, but it's wrong. And let me check. Pretty queue. Okay, in this moment I move to the next step, taking this as a, okay, now it's working. It's not working, but do you imagine that it's working? Yeah, because I don't want to spend many time trying to resolve this, because I know that it's possible, but I prefer to move to the algorithm, yeah, and come back to the final to this, because again, I think that I need to spend many time here. But well, in this case, for example, okay, is sort. What is the next? The sort of this element. I will take this as a reference. This is the input of the scale, and sorted this is basically command. Okay, is 1. I move this. This. Aha. This is the way. This is the current priority queue, having the first as a 1 and 3. Yeah. Okay. Now the next that is okay. Get the first element. Let me check the priority queue. The insert add I don't remember what is the time complexity of this. I think that is I don't remember. I don't remember. Time complexity. Yeah, it's logarithm n. Really? Well, I think that makes sense a little, because it's basically you have sort the elements. It's only find the using the binary search, and yeah, I think that logarithm n time for unit. For remove the element is linear, and for pick element the size, yeah, this is constant, this is linear, and for enqueuing the queue, for add and remove is basically this. Okay, nice. Now in this case I need to remove all the elements, and I need a list with the intervals. List intervals, list, it's equal new array list, yeah, and this is basically the result. Nice, we are 7 in this problem. Okay, now the next that is we have the pretty key. Now is while we need transversal all the queue. In this case is heap is empty priority queue. Sorry, I forget the operations of the pretty queue. Recently I learned this topic and I confuse with the another data structure. Always happen the same. Is add, right? Add. Yeah, it's add. Okay. Heap is empty. It's not empty. Sorry, I need to respond something here. Okay, now where is Twitch? Here. Okay, now this is the heap. Now the next that is basically take the first element and compare with the next. Compare with the next. Compare with the next. Okay, in this point, I think that we can. Oh, and this is an interval, but well. In this case, for example, I need to save the prep. It's equal heap dot remove that remove the first low item. Yeah, in this case 1 and 3. This. Yeah, now we have the prep and we remove. In this case we need current. It's equal. Do you know what? I will declare current here for and only replace the value heap dot pick. No, remove no. I think that I can have the two values here. Prep it's equal this and this. Yeah, and for example in this case this contain 1 and 3 and this should be contained the 2 and 4. Yeah, now we have this. Now the next that is compare exactly the elements prep to finish. Is finish? No, it's end. And basically is this. If this is greater than this, if finish is greater than no, if end is greater than start to the next. Sorry for my English, it's not my maternal language. Prep end is greater that current dot start. It happened this. Oh, it happened this. The next, the current element is inside the prep element in the range, you know. Okay, knowing this, basically we need to put again this value because we are merging the elements. Yeah, in this case is heap dot add heap dot add, in this case prep dot start and math dot max, because we need the maximum end between prep prep.end and start.end. Oh my gosh. Okay. Now, else, what happened when the current value or the current element like this is not inside, for example, this is not inside this. Okay, in this case, we found a common space, a common space that is exactly the answer. And basically here is a list dot add, and here it's a new interval with the values of prep.end and current.start. And here is heap.add current. But the problem with this is that in this could be I feel that this could cause an infinite loop. I'm not sure. For example, I take this and I remove this. Okay, now the queue only have these elements. In this case, I need to merge and appear a new one. The new one is basically this. Yeah, and now again, I take this because I save this and this. And is possible merge? Yeah. In this case, it's merge, and we have the new one. Yeah. And add again. Now the next is taking this. In this moment, for example, in this case, for example, I add this new interval. I remove this. I compare, and we can set that we have one space between 5 and 6 this hour. Yeah, and means that I need this is removed because I don't put again. And only have this. I think that this should be changed to the size. I think that its size should be graded that 1. Priority queue size. Yeah, and yeah, sure. Okay, and I think that with this is enough, and the final we have this. Okay, now we need to solve this problem. In this case, priority queue. I think that here is intervals length. No, in this case it's not intervals. this is using an object. If this object have the start and end, means that it's not necessary this, because we know that it's only two elements, or in this case the properties, but I'm not sure. Let me search here. Okay, I am searching here, but I think that is with the compares. Compare sort list using compare, taking as a reference two values. No. Oh, it's similar like this. I need to implement the comparator and take it the first. If it's different to 0, this other case, return this. No. I think that is very similar like this. I will put here, but in this case, I think that I will remove this. Only here. It's not necessary this. And this case is, I don't remember. Compare. What is the initial capacity? Yeah, in this case this is right because it's the number of elements. It's okay. And this basically is the lambda that say the first element with the second intervals length. But the intervals length, no, in this case is 2. We have only 2 elements. What is the parameter that receive this? Okay, comparator, initial capacity. Oh well, but I think that is not necessarily the initial capacity. Okay, I think that I can remove and only have this lambda that said this is the first element and this is the second element. And now I think that here I need to do this. Integer r, it's equal, yeah, in this case is a dot start, b to start, and I'm not sure why is this. If it is different to 0, okay, let me check. first and the second. This method return the value 0 if okay, when is 0 r equals this, it's equal 0 now, but in this case when is diff to 0 are different. When is, you know what, different to 0 are different, yeah. In this case is return error. In other case I need return this basically. In this case is a.end and b to end. Okay, at least don't broke this. Now what is here? This is current heap. But in my case, yeah, it's heap. What is wrong? Yeah, because this should be put as an object interval. And now is this 0 0. Okay, first I need to validate that the heap have the right sort order. Okay, I think that I can discover taking the first element. For this, should we have 1 and 2 and 1 and 3? What? Yeah, sure. I need to fill the heap. I forget doing this. Okay, a 4 that is a list. Come on. Is a list of interval L schedule, and inside this another that is interval L, and now is heap.add. No, yeah, it's this. Oh, yeah, okay. Damn. What is the error? I'm sure that is for 1 equal, or yeah, minor equal or something like that. Because in this case 94 94. What? 94 94 is only on this 94 94. if the start and then end are equal, don't add. I think this something like that. But I'm not sure if it's okay, nice. It's not my best, it's not the best solution, but well, works. Now I need to remove this. What? Yeah, sure. I remove the. And this is wrong. Yeah, it's this. When r is different to 0, are diff number and return r. Here I will leave a comment and sort the elements by the start, but no, n when r equals, use the n as a reference to sort it. Working, remove, fill the elements, remove this, remove this. I think that the complex in this problem is that create this logic. It's the second, no, maybe the third time that I need to sorry, I forget the what I was saying. Yeah, I think that this is the hardest part because yeah, it's easily forget this. Okay, solution using min heap Java. And the answer yeah, I think that okay, nice. Now let me check if I can improve. I think no. I only have the here. If this else, I convert to else if, putting this as a conditional here. But another point that yeah, is the only thing. Let me check the solution submission. Sorry. Is this in runtime? In memory? Yeah, I think that is because I am using the objects and this stuff, but okay, let me check the another solutions. Java. okay, in this case use we have the intervals. For example, here sort the intervals. Yeah, I think that if you sort, it's not necessarily the heap. I think that is the same. Maybe the sort. No. Time complexity. Heap. Pretty Q. No, but I want the pretty Q. No. Versus list. Come on, I need list type complexity operations. No, it's not a linked list, it's a simple list. Array stack queue single linked list hash table b3 red black. Array list. Is constant to read and to get, and for the pretty Q is constant too, because always take the first. For remove and delete it's linear. For add is constant. Okay, I think that is for this reason, because in the pretty Q time complexity in a time to time complexity. For the Q in the method is logarithm n. Remove the objects is linear. Yeah, I think that for this reason is more faster. If I change this to the list, I think that I will get a better improve. But well, a better performance, sorry. But well, I think that in the next session I will improve. But well, thanks for following this transmission, and I hope see you in the next. Bye bye.